Now we come to this S-28. Now we are going to solve some Cauchy inequality. So what's the define a Cauchy inequality? So definitions. The statement we already know, or definitions we already know. The integral of f of z divided by z minus c dz. So equal to 0. So inside and outside the circle and boundary of the circle, we already familiar about that. So what's the Cauchy inequality states? If f of z is analytic inside and on the circle C with the center at z equal to a and the radius r, then absolute values of nth derivative of f of a less than or is equal to m into n factorial divided by r power n, where r is equal to 0, 1, 2, 3, etc., where m is the positive number such that absolute values of f of z less than or equal to m for all z on C. This is the statement of Cauchy inequality. So what we already know in the previous slides. So some problems and Cauchy conditions and Cauchy inequality. So what's the definitions? What's some examples and problems? So in the state of inequality statement says if f of z is analytic, so f of z is analytic inside and on the circle C with the center at A and the radius R, then absolute values of nth derivative f of A less than or is equal to m, where capital M, then n factorial divided by r power n, where n is equal to 0, 1, 2, 3, etc., where m is the positive number such that absolute values of f of z less than or equal to m for all z on C. See, from the Cauchy integral formula we already know. So nth derivative f of a is n factorial divided by 2 pi I integral of f of z divided by z minus a to the power of n plus 1 dz. So this implies I take absolute values. So absolute values of nth derivative f of a is equal to n factorial divided by 2 pi I integral of f of z divided by z minus a whole power n plus 1 dz of absolute values. So that is means you take constant outside. So suddenly this number is less than or equal to absolute values of n factorial divided by 2 pi I, absolute values of 2 pi I, integral of absolute values of f of z divided by absolute values of z minus a whole power n plus 1 absolute values of dz. Suddenly this number less than or equal to, so we know this number is bounded. So absolute values of f of z is bounded, is given on the statement. Suddenly we can write this number is m. So suddenly less than or equal to n factorial divided by 2 pi. So integral of m divided by absolute values of z minus a whole power n plus 1 absolute with respect to dz. So again I am simplifying. Suddenly this number less than or equal to n factorial by 2 pi I. So integral of m divided by r power n minus n plus 1. So we know this means, so this is the terms absolute values of z minus a whole power n means equation means it is center means complex number to center as a and the radius r. Simply we can write this means this r. So absolute values of z minus a we can write simply we can write r means the circle with the center. It's a complex circle with center as a and the radius r. Simply we can write z minus a equal to r. So this means this less than or equal to n factorial divided by 2 pi integral of m divided by r power n plus 1 absolute values of dz. Since so C is such that mod z minus a equal to r, that is this implies absolute values of nth derivative f of a less than or equal to n factorial. M is a constant we take outside. So 2 pi r power n plus 1, again this constant integral of dz on C. That is if you take z equal to a plus r e power I theta. So z equal to a plus r e power I theta. Differentiate with respect to theta, we get dz equal to I r e power I theta d theta. So take absolute values. So there absolute values of dz we can write r e power I theta. So simply integrate and substitute here. So nth derivative f of a less than or equal to n factorial m divided by 2 pi r power n plus 1 integral run from 0 to 2 pi. So absolute values of dz we can write half d theta, or substituting r d theta. Suddenly this number less than or equal to n factorial m divided by 2 pi r power n. R power n. So where r is constant, take one term get cancelled. Simply write n factorial m divided by 2 pi r power n. So integrate. I'm integrating with respect to d theta, we get theta. So applying the limit run from 0 to 2 pi, as substituting theta should be 2 pi. So here 2 pi get cancels. N factorial m divided by r power n. That is, thus absolute values of nth derivative of a less than or equal to m times n factorial divided by r power n. R power n. Now this is the time is a Cauchy inequality. So this statement is the something this suddenly is bounded, that number should be m into n factorial divided by r power n. So one more we come to the Cauchy inequality, the theorems, Schwarz lemma. Simply say a Schwarz lemma. Suppose we take f of z is analytic in a domain D defined by absolute values z less than r. Secondly, absolute values of f of z less than or equal to m for all z in D. Third one, f of 0 equal to 0. Then absolute values of f of z less than or equal to m divided by r, absolute values of z. So also in this inequality occur for any one z. Then f of z equal to m divided by r z e power I alpha, where alpha is a real constant. This is a Schwarz lemma, simply says. See, f of z is analytic in a domain D. Now, so mod z less than r. So strictly less than r. So secondly, mod z less than or equal to m means is bounded. Simply say is a bounded. M is a positive number, positive real constant number. So f of 0 is 0. F of 0 is 0. Then absolute values of f of z suddenly less than or equal to m divided by r into mod z. So this equality simply we can write, also we can write z in for any z, f of z equal to m divided by r z e power I alpha, where alpha is a real constant. So again I recall where proof, let C be a circle such that mod z equal to r less than r. So r capital R. So by assumption that one is, what is the f of z is analytic in the domain D, then define mod z less than r. So by assume one, f of z is analytic within and upon this circle C, then by Taylor series, then simply say Taylor theorem, say f of z equal to summation n run from 1 to 0 to infinity. F of z equal to summation n run from 0 to infinity a n z power n. Simply say a power series at any point z within C. Simply pause. So expand this summations. So f of z equal to a naught plus a1z plus a2z square plus a3z cube plus a4z raised to 4, etc. Using the assumption, third one, f of 0 is 0. So replace z is 0. C means that is f of z equal to 0. When z equal to 0, we get a equal to first constant. A naught should be a 0. First term. A naught should be 0. Now by 1 become, so f of z equal to first constant should be 0. So f of z equal to a1z plus a2z square plus a3z cube plus a raised to 4 z raised to 4, etc. Then taking capital F of z, simply we can write, I take the f of z divided by z. So f of z equal to f of z divided by z, we get. So f of z equal to a1 plus a2z plus a3z square plus a4z raised to z cube plus etc. So we are taking z as a common, we take that, should be taking z as common, we divided that number, we generally we can write. So a1, so take this z, take z as a common, we get a1 plus a2z plus a3z square plus etc. I take denominator, so f of z divided by z. We can write that number should be, that function should be a capital F of z. So we get that is the name. So I denote that f of z by z. So a1 plus a2z plus a3z square plus etc. Now the function f of z, capital F of z, gives by 3 has the singularity at z equal to 0. As singularity at z equal to 0. which is removed if we define. So f of z equal to a1 for z equal to 0. First, if any function is constant, the function z equal to 0 because the singularity. If f of 0 equal to I, call this should be a1. Now f of z is analytic within upon C, and so by the maximum modulus principle, modulus of f of z attains its maximum value on C. Say z equal to a, so it attains maximum value that on C, say at z equal to a, and not within C, then absolute values of a is equal to or less than r. And so f of a equal to maximum values of f of z. So maximum values of f of z, capital F of z is already known, absolute values of f of z divided by z. So suddenly this number less than or equal to the constant m divided by r. Suddenly this number less than or equal to m divided by r. So absolute values of f of z less than or equal to m is given already on this statement. So mod f of z less than or equal to m is statement. So f of alpha means, so we replace f of alpha should be equal to maximum values of f of z. So if we take maximum values of f of z should be equal to f of alpha, we denote that maximum values of f of z divided by z should be equal to less than or equal to m divided by r. So again I take absolute values of f of z less than or equal to m. So what's f of z means absolute values of f of alpha less than or equal to m by r. So again, if z is any point inside C, then absolute values of f of z divided by z. So absolute values of f of z divided by z equal to f of z. That should be less than maximum values of f of z is equal to absolute values of f of alpha. Suddenly this number less than or equal to m divided by r. So these functions we replace maximum values of f of z should be f of alpha. Suddenly this number less than or equal to m divided by r. So this means the statement say it come to the star form. So absolute values of f of z divided by z less than m by r. This implies f of z equal to r, f of z less than m absolute values of z divided by r. So this inequality hold for all r such that r less than r. Now LSH is free from r, making r tends to r. So LH in the left hand side is a free from r. So taking r tends to capital R, that is absolute values of f of z less than m divided by r. Absolute values of z for all z such that mod z less than r. So in this C we are observe f of z equal to alpha 1, then z equal to 0. F of 0 is alpha 1. So this is the maximum values of f of z. So I am replacing this maximum values of f of z, denote that number should be f of alpha. That number suddenly less than or equal to m by r, m divided by r. So again by using the statement of form, so my absolute values of f of z by z equal to f of z less than maximum values of f of z. Suddenly this number m divided by r. So again, according to Cauchy inequality, if f of a is equal to m by r, absolute values of a. So if r tends to r, making r tends to r, f of a should be equal to m divided by r. So f of a. So you take that f of a should be absolute values of a. So if you're making r tends to r, absolute values of f of a equal to m divided by r, absolute values of a. So then f of a is equal to m by r, a e power I lambda. So take that should be, so this implies f of z equal to m by r, z e power alpha for z on C, where alpha is any real. So remark, you observe here in the one, so f of z equal to, if you differentiate f of z in the power series a n z raised to n, so a naught z naught to the z naught plus a1 z plus a2 z square plus a3 z cube plus etc. If we differentiate with respect to z, we get your derivative f of z is a1 plus 2 a2z plus a3z square plus etc etc. So replace z equal to 0. Derivative f of 0 equal to a1, that denote is equal to capital F of 0. This is the problem. If you substitute or replace z by 0, if you replace z by 0, suddenly we replace derivative f of 0 is equal to a1, that is constant, that replace capital F of 0. The problem is same as that. So let f of z be analytic in mod z less than or equal to r, and absolute values of f of z less than or equal to m on mod z equal to r. Then prove that derivative f of 0 less than or equal to m divided by r. So derivative f of 0 less than or equal to m divided by r. The solution is from the theorem on the previous theorem says that f of z equal to m divided by r z e power I alpha. So if it differentiate this function with respect to z, derivative f of z equal to m by r is constant e power I alpha. Differentiate with respect to z become 1. So suddenly we get m by r e power I alpha. E power I alpha. Or if you replace z equal to 0, derivative f of 0 is equal to m by r e power I alpha. So take absolute values. Absolute values of derivative f of 0 is equal to m by r. Absolute values of e power I alpha. Suddenly this become 1. So suddenly we get m by r. So from 6 and 7 you observe. So absolute values of derivative f of 0 suddenly less than or equal to m by r. So we in the statement, in the Cauchy inequality in the statement, we are prove some of that. Means, so this is the problem. If f of z is analytic in mod z less than or equal to r, suddenly f of z less than or equal to bounded, means this is the number is bound. Suddenly mod z is equal to r, then we say prove that derivatives of 0 should be suddenly constant divided by r. So this is the